Okay, I'm very pleased to introduce Victoria Rayskin, who is at Haverford College, a fine old Quaker school in Pennsylvania. And so take it away, Victoria.
Thank you very much for the introduction, and thank you for mentioning my project on the digital platforms. I am actually going to return to this project in the talk and talk a little bit more about the digital platforms traffic. So I started at Haverford College this year as a visiting faculty, and I was very much impressed with the course that I was assigned to teach. It is Calculus 2, just one step higher than Calc 1 in the previous talk. And this is, I would say, a very non-traditional level course where I have to teach very non-ordinary level to teach ordinary differential equations. So the students, of course, just had Calculus 1, and they are asked to learn differential equations via exploration and via some technology tools. So I would like to talk about the structure of the course. So we discuss the tools that I used. The most exciting part are projects. And then I will talk a little bit about the project development and TA's role, which is wonderful. So the structure of the course is the Discrete Dynamical Systems, DDS, which culminates with the project on DDS. Then we talk about differential equations, and again, there is a very exciting project at the end of differential equations, and differential equations motivate the subject of integration. So integration just comes as a tool for solving differential equations, and it ends with kind of traditional boring exam. So what we cover is everything via exploration. We use some visualization tools for looking at the orbit of discrete dynamical systems, and we talk about fixed points, periodic orbits, bifurcations, and then we do similar stuff in two variables. We discuss also stability of two variables, DDS, and then we repeat similar things in smooth case for smooth differential equations. And the interesting thing is that projects are very similar. So students have an opportunity to understand the connection between discrete case and continuous case of very similar problems. So I would like now to talk about the tools that help students to talk about the differential equations. So I will probably go to this screen. So first of all, we look at the orbits, and I'm showing here I hope that the Mathematica is visible right on the screen. Okay, so we consider the differential equation 0.5x plus 0.49 1 minus x times x, logistic differential equation, and looking at the orbit with, let's say, initial condition 1, the seed. So the students, just with the help of this tool, are able to see the convergence, and they conclude that there is some tendency in this equation, so there is a fixed point at 0. So just regular logistic equation, nothing fancy. So then we can look at the same differential equation with the graphical tool. So again, we can see that everything converges towards 0. And another exciting tool, the cobweb, that also confirms this convergence towards 0. And here we can understand the graph, and we can learn that the intercepts with the diagonal produce those stationary points, fixed points. So the equation that I show here, actually, I'm going to consider them in the project, and later in the project, the goal is to discover bifurcations. So this equation has also periodic orbits, and when we study periodic orbits, we can again observe them numerically. We can look at the tool that shows oscillations between the orbit points, and so with the help of these tools, students develop numerical techniques, and then we can also learn how to calculate these stationary points, stability, and bifurcations on the paper. So the bifurcations we can also explore with some Desmos tools, looking at various parameters for the equations and estimating the fixed points, and then the bifurcations when they occur as the intercepts with the diagonal. Okay. So as I said, the most fun part in this course is the project development. And students receive a letter from Miss Nicole Bloom, who is the owner of the internet platform Dynamic Sales. The platform assists registered users in sales and purchases. And if somebody is planning to sell, they have to pay $50 monthly fee. So I decided to change sort of traditional population dynamic equation or infectious disease equation with something that students can associate with their current work, since they are working on the digital platforms. So now they can also think about the profit of digital platforms. So the problem is stated in such a way that after some users register to sell, they successfully sell their items, and then they drop from sellers group after the successful sale. But because buyers are so much impressed with the functionality of the platform, after this term interaction with sellers, they decide to join seller's side. So we obtain this logistic equation. And now, since students have lots of tools in their hands, they can study this logistic equation with the tools in their hands. So we can ask various questions. First, try asking them to play with some specific initial conditions to explore long-term behavior of the equation. We can then ask them to explore the role of the parameter of the interaction term when buyers interact with sellers. We can ask them how, for example, to double or triple the profit of the platform owner. So this is all comes in the letter of the platform owner. So how to improve this parameter of the interaction that depends on the functionality of the platform. So how to triple long-term long-term profit of the platform. So students supposed to figure out the bifurcation points with the help of Desmos, for example, or with the help of Mathematica tools. And also the platform owner who previously received some help with from summer intern. So she asks help in explaining the equation with several methods. So students supposed to use several different techniques to explain their results. So the so students supposed to use several different methods to analyze fixed points, analyze stability, construct bifurcation diagram, and also provide actionable recommendations for profit of the platform. So we expect students to explore with the help of the tools and then to confirm with their calculations the results. Hopefully they will show this type of bifurcation diagram. They will find the point of bifurcation where stability changes, where the periodic orbit appears. So they're supposed to find all these values first via playing with the tools and then confirming numerically everything. So the process of this is quite challenging problem for Calc 2 students. And the process of the project development is also very interesting. So students work in groups of 3. So they write the project together, and then they submit this paper for review. So their paper is reviewed by other students, and each group is receiving 3 reviews from different groups. While they're reviewing other students' papers, of course, they also learn something from their papers, and then they can improve their own paper. So there are very clear guidelines how to write review for their classmates, how to do the assessment of their classmates' paper. They receive assessment criteria, suggested comments for the review. And finally, after this exchange of ideas and receiving reviews, the project is submitted for final grading. And then the same process is repeated for a 2-dimensional system. So of course, we can transform this 1-dimensional DDS into 2-dimensional if we introduce 2 variables, sellers and buyers. So they can compare this 2-dimensional DDS to their previous results. And again, the same peer review process is repeated. And finally, they submit, so they submit this for grading, and then they consider similar ODE model. So with ODE model, the process is repeated, and again, they can compare their results for discrete and continuous dynamics. And there is a great role of TAs in this process. Without their help, probably students wouldn't improve that much, that significantly. There is flipped classroom. So there are activities during each class meeting where they exercise, where they learn how to use these tools, how to put together their results, how to derive certain conjectures from playing with the tools. And of course, they use TA's office hours. And as a side effect, TAs also learn much more in dynamics than they would probably learn just from taking a course on dynamical system. When they interact with students and explain them various questions, they learned, I think, very noticeably. So as a side effect, one of my TAs in the course, Calc 2, took Scudam competition, also organized by Brian. And so they even won meritorious award. So it was a lot of fun to apply the same tools, to apply some ideas from the course for the construction of differential equations for Scudam competition. And I will probably end a little earlier than I expected. Just want to show the book that was very useful with many wonderful examples. So I've decided to contribute the project, which was based on some of my research work on the traffic of internet platforms. So the project even has some connection to reality, to some real data on internet platforms. So I will thank you for your attention.
Thank you very much, Victoria. I mean, Victoria has raised lots of issues, from student peer review and feedback to a complete report to an end of semester project. Any comments or experiences that anyone else wishes to share about some things they've done like that?
Hi, I actually have a question. And by the way, thank you for the talk. I really enjoyed it. I'm also teaching calculus 2 this semester, but I'm doing the more traditional class. Anyway, I have a question about the timeline for all the project report that you have your student do. So I see that you have the student submit, and then all the students will give them feedback and peer review. So how early the students have to submit? Like, let's say you have like a 15-week semester. At what point they have to submit their paper so that all the people have time to review, and then they have time to edit it and then submit it again?
Yes, so we are actually next week, students will submit their first draft. So the semester started 5 weeks ago. So we learn a little bit of discrete dynamics, and then there is a first draft. There is half a week for students to give a feedback. And then they have to work again on the paper for about a week to submit the final version. So it's a little lengthy process, but it worked well last semester.
Okay, thank you.
The final product for the teachers to read is better as well because of all the peer reviews. I mean, you're getting free editorial suggestions to enhance the reading so that you don't see these horrible errors that we all make. So there was someone else who had a question, a comment.
Yeah, I have a question. So when you're doing the discrete dynamical systems, Do you have them determine the stability of the equilibrium values using derivatives?
Yes, definitely. So I'm sorry, there is echo. I'm not sure what happened with the microphone.
Yeah, I can hear you.
Okay, so yes, of course, the students first experiment with the tools, but they, of course, have to then apply derivatives. They can also confirm their answer with the screenshots of what we call bow tie, for example, one of the methods. So let me show you maybe with Desmos, for example. They can also look at the angle of the intercept and what we call bow tie. If it's less than 45 degrees, like within -1, -1 slope. So if it's within this bow tie, then it's stable. Otherwise, it's unstable. But of course, derivative is necessary part of the solution as well.
Right, and because they find that the bifurcation point is where the derivative equals -1.
Well, yeah. So when, for example, on that picture, yeah, so it should go, for instance, here through the derivative equals 1 to change stability here, right?
Yeah. But at the 5 halves point, where you get the pitchfork bifurcation, at that point, the derivative of the equilibrium value is -1.
Yes, and then they have to consider the composition of two functions.
Right.
To see the behavior, to see the first they can explore periodicity via this tool. For example, they can see periodic points here, for example.
Mm-hmm.
And then they need to find the value of the parameter where this bifurcation, this change of behavior occurs.
Yeah.
Yeah, so analytically as well. Yeah, so they have to show at least a couple of methods to confirm the results.
And you have in your talk given us pretty much the instructions and the requests of the client that the students have to address very nicely, so that if someone were looking at this presentation, they could decide how to modify this themselves. I think that's terrific.
Yeah, I think the students enjoy the opportunity to sort of interact with the business world. Yeah. And to what I learned during my non-academic part of career, to provide actionable insights for improving their profit, for example.
Yeah, there's there was a Jerry Maguire is a classic movie with Cuba Gooding Jr. screaming, "Show me the money." And money talks. And I've used that video oftentimes in class. And so anytime you have a project that involves finances and maximizing profit is good. And the whole notion of having a client really enhances the student, because they know that someone really is interested in this. And even if they know it's a toy problem, they understand that someone could be asking this someday of their consulting firm or their team in a company. So I think this is terrific stuff, as well as good mathematics. I've used consultants often, and I wrote a paper, and if you want, you can send director@simio.org, and I'll send you a copy of it, about how you use yourself as a consultant. In other words, you walk in and play an actor. as a consultant, and then you walk out and then you come back as the teacher. And you actually pretend that you didn't even know who the consultant was. I mean, you can have a lot of fun. Tracy has a question.
Yeah, thanks. I enjoyed your talk. I have done it before, and I'm a huge fan of the peer feedback when the projects are a little more open-ended. I've never been brave enough to do it when I'm expecting everyone's answer to be the same, right? I'm worried that mathematical ideas are just going to get copied in that circumstance. So can you tell me your experience with that specifically?
Yes, I think students do use ideas of other groups. But I think it's okay if they learn how to solve. There are lots of questions in this problem. So yes, they copy some ideas, I'm sure. But then they have to submit their individual result. So they have to organize all their thoughts. And when I grade these papers, I can see if something is just a blind copy or they do understand what they learned from the reviewing. So it's pretty clear from grading.
Yeah, okay, so you did have to shift through that a little bit, but you found it wasn't the majority, I assume.
No, I mean, they discuss everything in groups of 3. So
right.
They already have help of their classmates. So I think it's all right. Of course, they didn't copy everything like from the beginning through the end.
Sure, understand.
Yeah, I think they kind of observe the honor code, and they're good students.
Okay, thank you.
Yeah, it's also when you have some students looking at other students' work, everybody knows who the superstars are in the class sometimes. And it's nice for the middle of the road kid to look and go, that's how she did it. Because they can learn from that. And at the same time, on occasion, they can make themselves feel good by going, well, at least ours wasn't that bad, and I can help this kid. So I think peer review is, in a situation where it's non-competitive, it's very helpful. So any other comments? No?
Well, I just wanted to say again, I enjoyed the talk, and the reason I brought up the derivatives is I think starting the course, Calc 2 with discrete dynamical systems, where they're using the derivatives that they've learned in Calc 1 to determine the stability of the discrete dynamical systems, it helps make a nice transition between those 2 courses.
Yeah.
Yes, definitely. Yeah.
If there are no further questions, we're going to take a break. And at 7:30, we have several interesting sessions. 8 o'clock after dinner, we're going to learn how to cook a turkey. That's probably a little late for dinner. The last session this evening has speakers, one from South Africa and one from Azerbaijan. I think they both have interesting things to offer us, and I hope you stick with us for a while. And I know that this is a Friday night and some people have been drained all week, but I think you might find the sessions worthwhile. And then we'll come back tomorrow at 12:45 on a Saturday so you can sleep in, unless you have a little baby, then that's a different story. But I want to thank Victoria again for her contributions in the past and for this marvelous amalgam of so much mathematics and communication. So we'll sign off for now. And
thank you very much for the opportunity to present.
Yes, take care. Bye-bye.